Now we're talking about polygons. So what's a polygon? No, it's not a dead parrot. Get it though? Polygon. Oh, that's so funny. So what you're going to do is to come up with what you think a polygon is when you do this Desmos activity. So come on back really quick after you do your polygon card sort. Okay, so maybe a polygon is going to be, let's see, I don't think I asked you for it up there. Okay, so a polygon, we're going to say, is a closed figure. Okay, you can't have any segments that cross each other. It's a closed figure that's made of segments. That's a good definition of a polygon. And when we name a polygon, we name it by its vertices. So before I get to this chart, let me throw this chart over here for a second. Go over there for a second, chart. So it doesn't really matter where you start. So if you start at, say, A, you have two choices of direction to go. So if you go here to B, you have to go here to C, and then to D, and then to E. When you name a polygon, you have to name it by following around its perimeter. So one good name of this polygon, one way we can name this polygon is polygon A, B, C, D, E. That's fine. You can also name it, perhaps you want to go like E, D, C, B, A. You can maybe name it like C, B, A, E, D. All those are good. What would not be good is if you went like A, D, B, C, E, because that implies you're going from A to D to B to C to E, and that's no good. So you don't want to do that. So name it by its perimeter, going around the perimeter. And the vertices that are next to each other, and the angles that are next to each other, and the sides that are next to each other, they are all called the consecutive vertices. I'm going to throw that over there. So the consecutive meaning next to each other. And these are just some common names of ones that you should probably be pretty familiar with. And I'll be honest with you, as I'm looking through some of them, you know what? You should know 3, you should know 4, 5, 6, 7, 8, 9. A nonagon, okay, maybe, maybe not. But definitely the ones you should know are like 12 is a dodecagon, 10 is a decagon, octagon, hexagon, pentagon, quadrilateral, triangle. And in general, if it has way too many sides, like a 37-sided polygon, it actually has a name. You could Google it. But we would just call it, say, like a 37gon to imply it has 37 sides and 37 angles. I wouldn't, that's a tough one to draw. Eek. I have polygon DEFG, quadrilateral DEFG. What's a diagonal? So if you think about this diagonal, it's a segment, first of all, and it's a segment that joins two non-consecutive vertices. That's what a diagonal does. It goes across the figure. It joins non-consecutive vertices together. And we say that polygons are congruent if and only if their sides and angles are all congruent. Remember, congruent meant like same size, same shape. So I can take quadrilateral camp and put it directly on top of quadrilateral site. And this is why that ordering is important. This tells me that angle C is congruent to angle S because they're both listed first. It also tells me that segment MP and segment TE are congruent. So we want to pay attention to the way we order our vertices. That's going to be very helpful as we go forward. So here's a question for you to try. Which of these polygons is congruent to polygon ABCDE? Take a moment, see if you can figure it out. So this is where you really have to trust your markings and take a look at the markings here. Because if you look at the original figure, ABCDE, I see that it has two 90-degree angle marked. It has these two angles marked congruent, and this angle is marked as well, but it's not congruent to the other two. Likewise, I have pairs of sides that are congruent. Side CD, though, is not congruent to any other one there. So if you match up those markings, you'll get this one down here. And if we say its vertices correctly, we want to match it with A, B, C, D, E. So perhaps we start at N, because N and A map to each other. And then if we went A, B, C, D, E, we want to go N, P, Q, L, M. That would be the correct order to go. Now, I'm not sure if you got to finish the Desmos activity, after the card sort. If you did, you may know what these words are. If you didn't, I'll wait here for a second to see what they are. All right, so an equilateral polygon. Equilateral, equal, and lateral meaning sides. So it's a polygon with congruent sides. If the sides are all equal, it's equilateral. If the angles are all equal, it's equiangular. And if it's both equiangular and equilateral, we call it a regular polygon. So add some of those to your definitions.